Okay, so welcome to my Calgary Youth Science Fair presentation. I'm going to be presenting something I built, which is a computer language. And I know I have a few judges who have computer backgrounds and a few judges who don't. So I'm going to be trying my best to kind of present it in a way where it'll make sense for both audiences. So what exactly is the goal of this project? So if you've ever tried or you tried to learn or tried to teach somebody a computer language, it can be hard. It's a new way to think, definitely, but it's something important that we really need to learn, especially in the 21st century. And the goal of the project is to make it a lot easier to learn and a lot faster to get your ideas onto a computer, into a program. You can think of it like a canvas, and I'm trying to create a tool that's much easier for people to put their thoughts onto that canvas. So I'm going to explain how it works, and then I'll do a quick demo of some of the cool features. So in order to explain how it works, we're going to have to take a little dive into computer linguistics. So here is an example sentence. It's cookies in a jar. And how would a computer process this? Well, we could first drop the article, because computers don't really need those. This makes enough sense to a computer. The a or the wouldn't really add any meaning. And then we should start categorizing the words. So cookies would be a noun, and so would jar. That's pretty simple. But a computer doesn't really understand what a noun is, so we call them expressions in computer linguistics. And an expression can be anything. It can be a math equation, it can be a list of numbers, and it can be like a cookies, jar, any sort of phrase. And the last one, it could also be a true or false value. And there's a bunch more that it could be, but these are the essentials, the simplest ones. And so cookies and jar would not be nouns, but they would be expressions. And you're telling the computer that there is this expression, and they're somehow related. And that description could be considered a sentence. We write computer programs in lines, and each line is a different sentence. It's saying a different thing. And we don't call them sentences, we call them statements. You're stating something. You're stating that there are cookies in a jar. You're stating that this variable exists. You're trying to initialize a variable. And so this is what a typical computer program would look like in my language. You've got 3 statements. The first statement for each I from 1 to 100. So what this says is take a variable I and assign it a number 1. And then what do? You go to the next line and you do some stuff with that I, and then you go back and you assign I to 2. And then you assign I to 3. And then you assign I to 4. And then all the way up to 100. And what it's going to print out is I squared each time. So it'll be 1, and then 4, and then 9, and so on. So this is a very typical construction in programming. This is called a for loop. It's one of the most basic programming concepts, very essential to programming. And so what would this look like in a more typical language? In C, another programming language, this is what that same program would look like. And to a programmer, this is super simple. This is like reading a very simple sentence. But to someone who's trying to learn how to program, this is very cryptic, and it makes no sense at first glance. If you took some time to look at it, it might start to make more sense. But the goal of the language is really not just to teach people programming, but if I just wanted to write a program, I'm not that great at programming, or I haven't programmed in a long time, it's going to take a while for me to remember all of this and remember all the syntax and where to put all these semicolons and these curly brackets and everything. So yeah, how about I just show you a few things we can do in this programming language. Okay, so this is I have a file open. And this file essentially is where I can write all the code I want, and this is what the interpreter for the language is going to interpret and then execute. So we can take that same example from earlier, for each I from 1 to 100, and it's going to print, which just means it's going to like spit out that value, I squared, and that's it. So we're going to run this. Surely enough, it did it very quickly, but 1, 4, 9, 16, 25, 30, all that, right? But this is like not that impressive, right? We could make this a little more easier to read. Instead of caret 2, like this, like a typical construction, we can just say I squared. And same thing. We could also simplify for each. So for each is a term that most programmers would know. However, it doesn't really make that much sense. You know, it's kind of like you're taking every I and then you're using it to do something. And so in my language, there are a lot of aliases or synonyms for certain phrases. And for each is one of those phrases that has a lot of synonyms. So one of those synonyms we could do is using every. And it kind of now describes what the program does. It uses every I, every variable I, from 1 to 100. And as you can see, we get the exact same value. Nothing changed in the output of the program. But this program now looks a lot friendlier, and it's a lot easier to read. It kind of reads like an English sentence. Using every I from 1 to 100, print I squared. And that's the program. So in order for a language to understand this, it needs what's called a grammar. And so in English, we have grammar. In French, we have grammar. In every language, there's grammar. But it's very hard to describe that grammar in a concise way. For spoken languages, that is. But for computer languages, it's actually relatively simple. This is what a typical grammar for, well, this is what the grammar for this language looks like. I'll zoom out a little bit. As you can see, this file, this grammar, describes every single valid statement in the programming language. I don't have a lot of time, so I'm not going to go super in-depth, but as you can see, a statement or a sentence can be any one of these things. And that can be an assignment, it can be a loop, which is the one I just showed you. It can be an if statement, it can be any of these things. And a statement, or like these things are all made out of expressions, like we saw earlier. And then an expression itself has a lot of definitions. It can be a string, it can be a list, it can be, you know, all these different programming things. And if you just look at the names, and if you're a programmer, you might know instantly what each one of these things are. But I'm not going to get too technical. I'm just showing you this because this is something we cannot do with spoken languages. We can't really take a piece of paper and write down every single grammar rule there is for English or for French or whatever language, because there's a lot of exceptions and there's a lot of variety in the way people speak, and you know, we're humans, we can't really do it so precisely, but a computer obviously can. And so the problem is that I kind of have to make a computer think like a human. And so what I did is I defined another file that has all these aliases. And so for things like multiplied, instead of putting, the typical way to multiply would be to take, let's say we wanted to do 3 times 3, it'd be this little asterisk. And that's going to give us 9, right? However, if you're teaching programming to a little kid, for example, and it's kind of hard for them to understand all these new characters on the keyboard, you can just write times, 3 times 3. That looks super, English-like and gives us the exact same output. And there's a lot of things in here that have that same property. For example, here's for each, and we have for each, we have using each, we have all these things. And a cool thing about this is that, let's say, not only did I want to add more for English, let's say I thought of a new one for each that I thought made a lot of sense, I could add it right here. But what we could also do is translate this language into a different language. So for example, if someone who was French wanted to learn programming and didn't have great English, someone else who wanted to translate all of this code would replace all of these English alternatives to French. So for example, for each would be pour chacun. Yeah, there we go. And I've just got to compile that. So now, once it's compiled, instead of doing for each, I could do my French alternative, pour chacun, I in. And so in is still in English, but we'll have to change that to something else in French later. But just to show you, we'll do I to the power of, I don't know, 3. And this works just, oh, sorry, this makes from I in from, there we go, from I from, there we go. So there we go, works just like that. And you could see I made a mistake. I put for I in from, makes no sense. So the computer told me it made no sense. I just read it normal, like an English sentence with a little bit of French in it. And I saw that in from made no sense. I removed it and then it worked. Okay, so for the last thing I'm going to show you, I'm actually going to write an example program. Let's say it'll list the prime numbers from 1 to 100, something like that. And so it is going to get a little more technical. So if you don't really care for that, then you can click away. But if you want to see what program writing looks like, then stick around. Okay, so we first need to make a function that will tell us if a number is prime. So define new function. This is a very verbose syntax I'm using. You could just do function, that works too. I'm pretty sure define, just like that works, but let's just keep it verbose for now. So is prime, it will take the parameter of num, and then if num is 2, return true. And for each I from, we can start from 3 to num. We don't want to include num because the ranges in this language are inclusive. So 3 to num will give every number from 3 up to the number. So we need to do num minus 1. And we can also skip all the odd, even numbers. Okay, so then if num is divisible by I, then we can return false. Yes. Okay, and otherwise we need to return true. And I think actually since we're starting from 3, we need to add another condition here. So I'll put it in bracket just to make it a little more readable. So if the number is 2 or 3, we'll return true. And oh, also if it's even, then we can return false. Okay, not the best function I've ever written, but it'll do for now. So let's check if 6 is prime. We'll check if 7 is prime, and we'll check if 19 is prime, and then sure, let's just check if 20 is prime as well. So there we go, we got false, true, true, false. So 6 is false, not a prime. 7 and 19 true, 20 is false. Great. Last thing, just write a little for loop for each I from. I'll actually show you a different range syntax here. This with the ellipsis also works. I in. Then we can say if is prime I, and actually this is also a valid way to call a function, the classic way. So we'll do that. If I is prime, we'll print and let's go up to 100 actually. Okay, hopefully this works. And there we go, 2, 3, 5, 7, 11. Yep, that looks right to me. So yeah, first time it worked because there's so many different alternatives, and my brain, it's super natural, right? It's just like I'm writing out a sentence. And I think it's really cool that you can talk to a computer like this and not have to translate, right? It's kind of just taking raw English sentences with a little bit of, you know, math and syntax and whatnot, and really turning it into a program. So yeah, that's my language. Hopefully I will be able to talk to you guys live in the award round if I get there. So yeah, have a great day, and thank you for watching.